Hello and welcome everyone. My name is Peter Robinson, and today we have Dr. Raghavendra, who is going to tell us all about Supra and Supra's new technology for containers and L2s. Um, Before you lead off into your slides, Raghavendra, could you please introduce yourself?
Yes, happy to be here. Thanks, Peter, for hosting me for this talk. Yeah, I used to participate in this very actively long ago, but now it's very sparingly, though. I'm happy to be back and to be in the community. Yeah, myself, I am Raghavendra. I'm VP of R&D at Supra. I'll be speaking today on Supra containers, which is more or less all about providing the experience of multiple app chains on a single layer one blockchain. Okay. I'll also argue that this novel concept unlocks many other use cases that may be held back because of the limitations of the current app chain space. Also, this talk will not be very highly technical. It is more or less concept based and articulating the ramifications of this concept. So I'm also interested in the feedback from the community, especially if people are there from the app chain space. Then I know I would want to know if I have missed anything that we have done some research on our end. So that means we want to be complete with regards to what we articulate as app chains. And if we have missed, we would want to hear from you. Okay, let me share the slides. Hopefully all of you can see my slide. Is it visible? Okay, excellent. Okay. Yeah, this is for the Ethereum engineering group. Let me begin with app chains. Okay, so these are some of the examples of app chains. DeFi kingdoms, which is an Avalanche subnet, and then DYDX, which is another DeFi protocol hosted on as on a Cosmos zone. Osmosis, another DeFi protocol on Cosmos zone. Unichain, we all know that it was recent where Uniswap branched out and decided to form its own app chain, which is a layer 2 solution on top of Ethereum. So these were some examples. Let's understand what exactly is an app chain. We need some starting point, right? The starting point is pretty simple, which is it is an app, it is a blockchain dedicated to an app or a group of related applications. Okay. But what it enables is the one which is what makes it appealing. It enables an app-centric business model, right? Typically in blockchains, you have network, you have the node operators who are hosting their computers, for the network, and the app creators or the app deployers, they deploy their smart contracts on the public blockchain, and the users use the services, and the transaction fee typically goes to the network. How does the app creator or the developers make any revenue out of it? Though it is the code of them that is being used, it is their product that is being used. There is no framework-wise, what can I say, a revenue model which is streamed to them. If they have to impose anything, they'll have to code it up in their smart contract level and extract some revenue out of it. But app-centric business model, this app chain enables precisely that. It gives the framework, it gives the entire blockchain for an institution or for a community which is centered around an application. So this enables multiple things. I'll come to it. One, and also it gives sovereignty to the creator or the community around this app. It means it gives control and authority to the community behind the application that includes developers, maybe users, founders, and many more actors to administrate and govern the traffic, setting up of the fee for using their services, the sharing of profits, the role of features, and how and when to introduce the updates to their application and everything. So how are these done? These, I mean, if we distill down these high level things of app centric business model and the sovereignty to the community, it boils down to small of these primitives, I would say. One is gated smart contract deployment. You can't be permissionless in terms of deploying a smart contract. Typically, these app chains, you need an approval from the governance of this app chain to deploy a smart contract. If you allow anybody to deploy a smart contract, then that smart contract would attract some traffic, and so the business model again goes not as planned. So it allows gated deployment of smart contracts. Also, the custom gas tokens, right? So typically, if you're on a public blockchain, the transaction fee is set to the coin of that blockchain, a native coin of the blockchain. In Ethereum, it's Ether. In Aptos, it's um, uh, Apt coin, and then in Sui, its own coin. In Supra, it would be its own coin, Supra. But you would want the consumers of your application to spend a currency of your desired currency of the app for any and every utilization of the service. So this is what it entails, these questions, to be able to provide a custom gas token, a custom transaction fee currency. Not only the currency, you should be able to set up your own gas price, right? It's not anymore um, uh, the dynamics of the gas pricing of a public blockchain. You are setting up the gas price for your own application, for your own chain. And it also enables localized fee market. That means when all the applications of the smart contracts are co-located in a public blockchain, say a hotspot, meaning a high demand for some smart contract, say CryptoKitties, will spike up the transaction fees for another completely unrelated app. Is that fair? The consumers of that app might say that, why are you penalizing me? I would understand if there is a demand for this app and if I am asked to pay more, but this is completely unrelated. So this is what precisely the localized fee market shows. That means if the demand, the fee market dynamics or the fee escalations should be restricted to the traffic pertaining to this app. So this is precisely the localized fee market. So as I said, fundamentally, the app chains are appealing and it's a hit, mainly because it enables app-centric business model and it gives the power and sovereignty to the community. So that's the main takeaway from the slide. The state-of-the-art solution, as we saw from the examples, typically these separate blockchains for these apps are, layer twos or, subnet or a shard or a side chain. The standard solutions available in the market are Cosmos zones, Polkadot parachains, Avalanche subnets, etc. Like a Uniswap used an L2 stack of Optimism layer 2 stack to build their own chain, Unichain. So this is the state of the art. What exactly is the limitation of this approach? So this is the crucial part that we would want to understand so that we go past it, right? Yeah, they have their own limitations. Naturally, one full blockchain for an app seems very heavy, right? Blockchain involves a network of nodes, node operators. They have costs running these nodes, and they would want profits for doing such an operation. So you'll have to incentivize these node operators and need to pay the rewards. And app chain is not a general purpose blockchain. So users typically are using services across multiple blockchains and they are coming to this app for the services of this application. So that means that would have naturally parked their assets somewhere else, and they would have to move their assets to engage in the services of this chain. That means that they necessarily have to engage in bridging multiple networks, bridging assets across multiple networks. Yeah, even though, let's say, as we said, the state-of-the-art solutions are Cosmos zones, Polkadot parachains, and Ethereum layer 2s. That means it might be in another layer 2, their asset, or it might be on another parachain or another zone. They still have to engage in bridging, even if it's within their ecosystem itself. So that seems unnecessary and undesirable. And yeah, that's what we argue for. And precisely for this reason of unnecessary isolation that exclusive blockchain brings, the liquidity gets fragmented. Suppose suppose an app chain wants to use stablecoin, right? They'll have to convince the stablecoin provider to deploy their stablecoin in their app chain. It's not seamless. For example, if we want to accept, if Uniswap wants to accept USDT on Unichain, then the USDT smart contracts have to be deployed. Even if it is deployed, the liquidity of USDT is again split from Ethereum to that Unichain. So not only for the institutions, for individuals and institutions alike, this whole exclusivity, this whole isolation that the app chain brings, maybe inadvertently leads to liquidity fragmentation. And this is again undesirable and unnecessary, as we argue. So yeah, can we host multiple app chains on a single layer one? So this was precisely the question asked by our CEO, Joshua Topkin. He showed that we are a high-performant layer one blockchain. Certainly, we have the opportunity and room to host multiple app chains. The question is, how? Can we come up with some way? He's the one who ignited the idea, led the thinking here, and the result is Supra containers. Okay, we have the white paper up on the website. Please do read and review, and your feedback is invited. So let me pause there because I crossed the app chain and now I'm going into the Supra containers. Anything any clarifications or questions people might have?
None from me, though. I know with my experience, the big things about new blockchains or new chains is liquidity. So getting centralized exchange support, on-ramp support, bridge support, like getting a good bridge to or bridges to want to bridge to your chain. And a lot of it is about money and allowing people the opportunity to spend money on your chain and do things. So I think that those infrastructure things and convincing those well-known infrastructure providers to provide infrastructure to your chain are probably the biggest thing. And whether you're an L1 or an L2, I think it's still the same deal, and hence it comes down to potentially communications between chains that already have that. But yeah, that for me, I guess that's tied up into your bootstrapping the L1 point.
Exactly. Yeah, that's good. So we kind of echo the same the sentiment with respect to the problem of the app chain to attract these liquidities, right? Yeah, excellent. Okay. Now, yeah, let's begin. What are Supra containers? We start from this point where we say that technically, Supra containers are nothing but a group of smart contracts, typically belonging to a single application or a group of applications. Okay. Now, now the question is how to enable app-based business model and facilitate sovereignty, which translates to how do we provide a way to set a custom currency for paying transaction fees? How do we provide a way to set a gas price? How to allow gated deployment of smart contracts? And how localized fee markets can be enforced? These are all, goes to the implementation of containers. This is work in progress in Supra Labs. Our research and engineering are well into it. So more or less, this entails modifying the components across the spectrum. We'll have to modify the transaction structure itself so that we identify that this transaction belongs to this container. So you need a container field there. And the amount that is set for the transaction fee has to be interpreted in the currency of the custom gas token, right? And then we'll have to modify the VM runtime too. The gas cost deductions are no more the ETH or the native currency based deductions. It has to be based on custom token now from the user, and then we'll have to refund it based on the amount that is unspent. And also the VM has to be modified to allow the container owners or the administrators to approve or disapprove a smart contract deployment. Okay. And we might have to have multiple smart contracts at the layer of smart contract platform itself to manage multiple containers, and also to enable block space quotas. I mean, block space quotas are the way to enable localized fees. Localized fees, that means you'll have to mark some quotas inside the block saying that this quota belongs to container one transaction, other 20% of the block space belongs to container two, etc. And how do we enforce that? Should we be strict there, or are there alternatives? So all these things are being done. Yep. And this is actually the focus. This is not the focus of this talk. This will perhaps make another talk. We'll come again onto the EEG for this another talk, which goes into the details of the implementation of these containers. And this is also VM specific. Like for Move VM, it will be different, and for EVM, it will be different. But the talk will more or less concentrate on other aspects to show how it overcomes the limitations of app chains. So another part that I would want to lead into is to show the analogy that the business model between a container owner and for now, think of container as an app chain or an app chain equivalent. A container owner or an app chain owner and consumers is like a private company, right? The consumers so far, if you see, let's say we enable all these things, the custom gas pricing, custom gas token, localized fee. So that means the users pay the container owners. So perhaps there is a cut to the network, but users pay to the container owners and they avail the service. So this is more like I should say a private company. So how to make this public in the sense that suppose we would want to open up the container, somebody to invest in my container so that he can reap some benefits out of the services that are being used by my container. Okay, so similar to when a company goes public, people buy shares of that company, and the company's profit, they get a cut from the company's profit too. So if we make the container as a company, how do we make this participation? So we introduce another role called block space lessees, where anybody can be block space lessee, including the container owner, and who are predicting the container traffic, saying that this container is doing very good. Let me, and I predict that there will be huge number of huge traffic of transactions in this week. So let me pre-buy the block space for it and allocate it. So typically, these lessees buy block spaces, build container traffic, and invest in them, and get a cut from the transaction fee, which will, like, now the cut is in three-way: container owners, network, and these lessees. So again, this is still more or less, we are wrapping up on this. It's the white paper will be out soon. This is again a full blown economic topic, and this will again interest another talk itself. We can again post that later. But I wanted to impress upon saying that just making the container technically available on a layer one is not enough. It's part one of the job. The part two is to be able to build an economy around it. And both, when they come together, is when they can become a hit. Otherwise, it's still not very convincing. So yeah, that's the part that I wanted to impress upon. Before going to the next section, which is the, or less the last section, which is about composability, and I would want to posit this as the distinguishing feature which container has, but the app chains don't have. I see that there are some things on the chat. Yeah, EIP 1559 for each container runs IV. I mean, EIP 1559 is the base gas price fee and the tip thing that happened, isn't it, on Ethereum? Yeah.
Yeah. And I was just trying to work out, when you were talking about block space, whether that meant that within, like, if I'm some app chain or app container, then do I get like 10% of the block space? And do I do sort of a fee market EIP 1559 within my 10%? Is that how you see it working? Or
Yeah, I mean, we have looked into the problem of gas dynamics from a first perspective, from first principles perspective, and we have complete paper on it. Again, it will be, I don't know if it's already public. So it's more or less wedded to that. So if we want EIP 1559 to be enabled inside container, I'm not sure there is any problem with that. It can be done. But uh, more or less, this whole thing makes sense when you have a very high throughput system and you have a very large room in your block space. Unlike Ethereum, let's say in Ethereum, you have more transactions in the mempool than the block can pack, perhaps, and the blocks are spaced 12 seconds apart. So the throughput is not high compared to the modern blockchains like Aptos and Sui, where we are trying to attack to the throughput of 100 kTps, 200 kTps. Recently, we also showed from our consensus itself, the moonshot consensus protocol and the data dissemination, we can achieve, especially with the core insight of Supra, with the tribe clan model, we can achieve 500 kTps. Now, the question is reversed. It's not that how do we find a space for a transaction? The space is there. Now, the question is like, how do we extract more from it? So in Ethereum, I think the scenario is different. The question is runs in EVM. Yes, it's every container is like at least if you think of an EVM, when we say container is a bunch of smart contracts, in EVM, every smart contract is associated with its own exclusive storage, right? So when we say that a container is a group of smart contracts, that means there is an exclusive storage for this container too. So the entire blockchain state, EVM state, can then be partitioned into the container state spaces too. But this may not be so in other VMs. For example, in MoveVM, the relation or the association between the module and the state space is not that exclusive, right? So in that case, it may not always result in a partition. So there is another dynamic going on. But in terms of EVM, yes, this leads to a partition. And later I'll show how this can be exploited for parallel execution of transactions too. Okay. Okay, let me move ahead then. So we said that we looked into the limitations of app chain, and we said that the isolation is the fundamental cause of fractured liquidity and the bridging problem, right? And this is precisely what the container overcomes. This is what containers looks like. For example, in a EVM state, there is a green container A, there is a blue container B, there is a purple container C, and there is a, let's say, public default Supra container. Let's say we are coming up with our own VM, with our own EVM version also. Supra is, as I'll mention later, Supra is hosting MoveVM to begin with. It will be launched with the MoveVM, but later we will be also launching an EVM. So the whole idea is to have multi-VM support in the layer 1 blockchain. Now, these containers are actually artificial boundaries. These are not exclusive blockchains, right? Composability is just a method call away. It's just a method call away. If, let's say, a container C has a stable coin, some ERC20 coin, let's say USDC, and or let's say more or less it will be more likely for a USDC to be deployed in a default container, let's say like the pink one, the red one here. And suppose then it can make available the USDC for container B as well as container C. Container B just have to call the methods in the in those contracts to make to get that to get the service. Not only the USDC, as I said, suppose there is a container focused on gaming application, and if it want to use a lending protocol, then it need not force for the container, like the app chains do, to be self-contained. It can actually use the services of lending protocols that are deployed on another container or a public default container. So yeah, as I said, composability is very useful. One can use the services that are popular in other containers for our own applications. As I said, lending protocols, game, and predictions. So what, in a sense, this means is the containers are not spinning up a new blockchain. So that means they don't have to bootstrap the whole ecosystem, as Peter was pointing out, all the money aspects. They don't have to uh, uh, worry about. In fact, the entire thing is taken out. There is a Supra layer 1 blockchain, and that network is secure economically because we are spinning up a new layer 1 blockchain, and we have nodes. By the way, our testnet is already live. It was launched on September 20th, and we have, I think I'll come to it, 120 nodes in that network. So we have a particular tokenomics for the node operators to stake and come to this network. So the entire network is secure, economically secure. That security is inherited to every container hosted on this layer 1. So they don't have to worry about security. They don't have to worry about costs, bootstrapping another network. So this is a low cost solution. Also, as I said, the isolation of app chain was a limiting feature. And I believe this combination of low cost solution and this composability will unlock new use cases. The people or the developers who may not have thought to go to the app chain route because of this high costs and isolation, or because of this restricted composability, will now evaluate this, and they will more or less come to this space of Supra containers, which is more appealing. They get to set their own custom gas token. That means they can build an economy based out of a new token of their own desired application token. They set the cut for the consumers when they are using these services from the transaction fee. They also allow public participation for anybody to come and invest in their container and and get a profit out of it also. So this whole cycle is economically very robust and very appealing for any app to come for Supra containers. So that's the whole game here. So as I said, because of this composability or seamless composability, we have unified liquidity. The bootstrapping is anyway avoided because of these artificial boundaries hosted on a single layer one. Now, and also for every transaction from the user, if you have an exclusive blockchain, you'll have to give more cut to the network because the nodes are running exclusively for your app. Now these nodes are running for all the apps on the layer one blockchain. So your cut to give to the network is substantially low. And as I said, it comes with the economic security of the layer one. So that's how it kind of overcomes the limitation of app chains. More or less, it inherits all the features of Supra. Supra is hosted or Supra is built on a high throughput and fast layer one blockchain, which hosts which is based on Moonshot consensus protocol. We published this in ICDCS, and we have demonstrated recently in a blog and a video too that we can achieve 500K TPS with sub-second latency on a 300 node network. Now this is with a 300 node tribe with 5 clans. That means each clan has a size of 60. As I said, the Supra has now launched a Move testnet on 20th September. So it's more than 1.5 months. Now it's running stable. Many apps are deployed and one can see that. Also, Supra is a vertically integrated blockchain. That means we recognize that blockchain is not an isolated system. People would want multiple services on the blockchain. And if we provide all those services natively, then it is going to appeal for the developers. For example, Oracle price feeds are necessary. We have a DORA protocol, and Dr. Saurabh Joshi from Supra Research, Director of R&D, gave a talk some time ago in EEG in this group about our DORA protocol, Distributed Oracle Agreement Protocol. The fundamental highlight of this protocol is we can now solve the problem in a simple majority model rather than a 2/3 majority or a super majority model. Our DORA is live on 67 mainnets, serving more than 500 pairs. Now, any application, any container that is hosted on Supra blockchain will naturally inherit this high throughput, low latency, the Oracle price feeds, and also we have on-chain randomness solutions with Supra DBRF, which is again live on 23 mainnets. This randomness is available locally and natively on chain. We are also working on zero block delay automation, that rather than making an individual or certain entity to trigger a transactions, can we automate the initiation of transaction? Let's say when the price of Ethereum hits Ether hits $5,000, then you sell my Dogecoin or something like that. So these conditional transactions can be done in automation. And this is again natively integrated into the Supra networks, which is one of a kind. And it enables zero block delay automation. That means we verify that the trigger condition is true, and then we just execute the transaction. It doesn't need to go through the mempool and batching consensus. We can maintain in the state, and then we can just execute the action based on the trigger. Again, another white paper is being worked on that. Very soon we will publish that. As I said, it's a multi-VM network. We already have a MoveVM testnet. There is an EVM testnet or staging net, as we call it, is upcoming. So again, the bridges, we have worked on the bridges. I'm going to give a talk in upcoming SDLT about Supra's blockchain interoperability solutions. We have two kinds of bridge, Hyperloop and Hypernova, which is a trustless bridge and a multi-sig bridge. These bridges will be deployed on the Supra layer one. So all the containers will inherit naturally this bridging capability through these bridges. That means they can access resources and assets and services that are there on the other blockchains through these bridges. Okay. So yeah, anything else? The highlight of this section was composability is the distinguished feature of Supra containers, and that helps overcome the limitations of app chains. Any question before I move on to the next section? Okay. Yeah, let me move on then. Now, as I said, automatically triggered transaction is a good feature. Yes, yes, there are already automation networks available, but it's like a third-party network. They run another set of nodes which maintain a registry of these conditional tasks, and they keep polling the blockchain or any other thing that's required to check for the condition. And when the condition is met, they submit a transaction on your behalf. So this is third-party network. We integrate that network into our blockchain, and hence it's a native thing, which enables us to do a zero block delay automation. Yes, automation will be a very highly useful feature, and we expect that it will be consumed heavily. So yeah, parallel execution. Now, containers, especially in the EVM setting, when it is giving a partition of the state, can be seen as an access specification. How? Like in if you recall in Solana, the transactions come with read and write sets saying that I'm going to read from these accounts and I'm going to write to these accounts. There is an access specification carried inside the transaction. Now, we are not bloating the transaction with those access specification, or not even we are burdening the RPC node to simulate or locally execute a transaction to generate the specification and attach to it. Because the transaction structure itself says that this belongs to this container, okay, naturally it's saying that I'm not going to access any of the or I'm not going to conflict with the transactions targeting other containers. If there are two transactions, T1 targeting to container C1 and T2 targeting to container C2, and if they are two separate containers, then they don't naturally conflict. And this information is available syntactically at the get-go. So one doesn't need to build a new dependency graph, or one doesn't have to mine this specification, it's already there. This is for the intra-container transaction. Note that our composability allows cross-container transactions too. So that means that that means that some transactions are accessing more than one container, but it can still make a case to treat the intra-container transactions separately, and let's say batch cross-container transactions separately, and deal with parallelization for inter-container transactions in a very simple way. So that means you can have a block split into, or virtually or artificially split into containerized batches. That means a batch of some transactions targeting container one, batch of transactions targeting container two, like that. Now then we can employ a simple work sharing queue algorithm. Imagine these gray circles or these batches of transactions, they are coming in, and then the red circles are the cores, are the CPUs that are running these transactions in these batches. They just have to, it's like a clerk and a, clerk and a people system where people go into who are available the clerk is, right? The clerks are signing documents or something like that. So the cores execute these transactions, and when they finish up, the next in the queue, the batch will go to the next available core. This is a very simple way where the execution parallelism can be introduced without doing any kinds of abort and retries. So this is not we're not proposing this as an algorithm. We are proposing this as container serves this access specification to yield such a parallel execution model. Okay, and we did run experiments on multiple workloads. This is the real world transactions from Ethereum. So block numbers are given here, and we made them, we looked into their state, what parts of smart contracts they are accessing, and we kind of artificially separated them and made 171 batches here. And if we leverage this specification, if we leverage this containerized specification, then not only that, the red one, this is the work sharing queue, as I said, outperforms the sequential execution that is expected. The right y-axis is the throughput, by the way. That means number of transactions you can execute per second. It will also outperform some of the vanilla parallel execution algorithms out there in the industry. For example, Aptos, Block STM, and then Solana C-level. It's not to say the algorithmic superiority here. It is to say the benefit that the container as an access specification yields. For a proper apples to apple comparison, one would have to push in these specification to these parallel execution algorithms to say, what is the best. But as a potential, this is what this shows very promising. Yeah, indicates a promise. Okay. Okay, I'm more or less done. 45 minutes is a good good space, I think. So in summary, what spoken is Supra containers are inspired by app chains, and they give the experience of app chains on layer one. In addition, it overcomes the limitation of app chains, especially of the fractured liquidity and ability to the requirement to bootstrap a new network. All those things are overcome by these Supra containers. And it's hosted on Supra layer one. That means multiple features, as I mentioned, Oracle price feeds, randomness, multiple VMs, the automation network, the bridges, they're all available natively. And also because it's a high throughput, high performant layer one blockchain, you have the speed, and you have the because of high throughput, we'll also, our gas costs are also low. Yeah, some of what we posit as the Supra containers as a win-win to the underlying layer one Supra, to the consumers, and to the app creators. It's a win-win for all. So as I said, we have our testnet is already live. Our mainnet is going to be live soon. It's launched soon. We'll also launch the Supra coin. We'll also list the Supra coin along with it in popular exchanges. There is 250 million Supra airdrop available for grabs via this Starcade games. Please go to supra.com. You'll have this all at your clicks. Feel free to participate and benefit with it from it. We also have a Star Key wallet that have been used, multiple users now. Yeah, here are the resources that I that for anybody to look into. One is supra.com posts all these things, all the details are available. Our research is very thriving, and we have a very highly talented research team in diving deep into multiple areas of computer science research. Not only computer science, like distributed systems, cryptography, game theory, and also in economics. Coming soon, maybe have all papers published on peer-reviewed conferences as well as white papers, but some more white papers are coming. Though there have been inventions and we have publicized these inventions individually, we were lacking a single white paper which can stitch all these inventions together and showcase what exactly is Supra blockchain infrastructure. And that is finalized now. Maybe in this week or next week, it will be put up as soon as day after tomorrow. So this will be a Supra blockchain infra tech stack white paper. As I mentioned, the parallel execution thing, which is only tip of the iceberg in this presentation, we have a host of parallel execution techniques which we can capitalize on, and we'll soon be putting up the blog post on that. And as I said, the main important thing for us as a company and for we believe as an industry is the Supra mainnet launch and the token listing. So yeah, all done from my side. I'm happy to take any questions or I couldn't include your slides, Peter. I mean, you'll have to share your own screen.
Sure. No, don't worry. There are lots of talks coming up, and the app merch store is still open. And yeah, I think most people know the socials. Yeah, just Google Ethereum Engineering Group if you're watching this on YouTube, and you'll find the meetup on meetup.com. Yeah, so very interesting. I look at the technology and I think the gas pricing in the token of the container you could imagine all sorts of attacks around that, where you try and do price manipulation and then do lots of transactions. And you've also got it's almost like a JVM sandbox sort of thing, about trying to make sure one container's code or execution doesn't leap out into another execution environment somehow, and preventing that. So lots of interesting things that, but yeah, I don't have questions as such. What about other people? Do people have, oh yeah, Lecky's got one. Could you talk more about how to solve the fractured liquidity? How does liquidity come from one container to another?
Yeah. So it doesn't have to come from one container to another. So that is the whole story. For example, let me go back to that slide where I had a picture. Yeah. So imagine that the red one, the public Supra default container, is hosting a stable coin. It's a USD. And let's say this is, I hope you're able to see my cursor. This is a smart contract, ERC20 contract of USDC. That means it hosts the mapping on who owns how much of USDC, right? Now, a container B is a gamified, or let's say a lending protocol or some app. It's based on in container B, and that wants to use the USDC, right? So that means it should be the smart contracts in container B should be able to call the USDC.transfer functions from A to B, right? We allow that method calls. It is not actually a pure sandbox. I'll come to it on comment on what Peter said. But this is allowed. This cross container method call is allowed. The only time at which for a container owner to disallow this is at the time of deployment of this smart contract. The container B gets to approve this smart contract deployment. At that time, they can inspect the code and say, hey, this does not conform to the policy. We mandate USDT, not USDC. So you'll not look into, you can't call USDC method call. So they can reject the deployment of the smart contract in their container. That is possible. But once it is there, the method call is not a bridging. It's just a static call or a delegate call, whatever it is. It's just a method call. So when a transfer happens, the USDC changes hands, changes accounts, right? From let's say from Peter to me or something, but we are still housed inside this container itself, which is available to be accessed by container B as well as container C as well as container A. So the liquidity is all stays in one place. Compared to the current approach, let's say these were Cosmos zones, okay, or these were L2s. Now USDC contract have to be deployed in container B or app chain B, app chain C, and app chain A, along with USDT deployed on Ethereum. And there, the amount of USDC held in the contract in Ethereum will have to split to the amounts in app chain B and app chain A and app chain C as L2s. So that's where the fractured liquidity happens because of this exclusive blockchains. And Yeah, because we remove that exclusivity and we make this artificial, we make this seamless. That's how we get the unified liquidity.
Yeah.
Optimist super chain.
So essentially, so I think this will help to answer Lecky's question. So essentially, container A, B, and C and the main chain, main container, they're, one of them could be move VM, one of them could be a EVM, and one of them could be some other VM. And is it that your call, so each time you call from one contract to another, say for instance, I want to use this much USDC or transfer this much USDC from this account to this account. Yeah, that's a call to a different VM or different container. And so that happens separately and then you return. So you're updating state across containers, but because they're all really one blockchain, it happens atomically. Is that a fair way of thinking about it?
Correct, correct. It is an atomic call
Yeah.
inside a single.
And so, yeah, Optimism Superchain, though things within that ecosystem are going to be fast, the liquidity is going to be reasonably optimized. It's still separate blockchains, essentially, or separate chains. So you're not calling within the one blockchain. And yeah, all right. So I think that and that's correct, isn't it? That is the correct answer to Lecky's question.
Indeed, indeed. It's the atomic composability that is that differentiates here. Yeah.
Yeah. And the reason why you can do this rather than say you wouldn't do it on Ethereum, which you could do it on Ethereum, but the reason why you wouldn't do it on Ethereum is because you've got 500,000 transactions a second and it's a new blockchain, so the transaction costs are really low. Whereas on Ethereum, you could do a container, but it would be a really slow container. And I guess you don't have the controls to allow you to do move VM in the blockchain client. Yeah.
Yeah, I mean, it's not only container as a single thing, right? It comes together as a whole, Supra as a whole. I mean, the whole Supra's thesis is vertical integration of multiple services on a single platform. So for container, all these Oracle prices, randomness, automation, bridging are available very natively at a very cheap cost in a highly performant way. So yeah, so that's the entire thesis. It is still possible for anybody to implement, but as I said, it's only the part one. It is not to full a puzzle still, because we still have to talk about the container economics part, which can make it even more appealing. So yeah, multiple things have to come together, I would say.
Yeah. Yeah, for sure. Sounds really interesting. So, Ethereum and Solana have a variety of people working on the technology. Is Supra going to move towards having a wider group of companies contributing to the tech stack?
I didn't quite understand the question. So we
Oh,
hope.
it's just that say if you've got I think so Ethereum, there are many companies that contribute to the tech stack, so you can feel comfortable that even if one company goes broke, chances are, like something the chain will keep on going, and there are multiple companies contributing and having innovation. And I was just wondering for Supra, is that something that you're heading towards,
Yes,
or
yes.
where are things up to?
Yeah, that is definitely the plan, the long term. But right now, it's we are launching the mainnet, and Supra is the only company which is working towards this mainnet and all these things put together on layer one blockchain. But once this becomes public and they are being consumed, and once there is good demand, then we certainly will open up for public participation. We can spec out things, and one can perhaps develop their own client for Supra. And already there are many other ways to participate anyway, like
Mhm.
for Yeah, there is another host of DeFi topics that we haven't covered, which where we have multiple protocols like DFMM, Dynamic Function Market Maker, and there is a DeFi intralayer. Um, for somebody coming at the application level, there is a standard way to participate. The one who would want to do it, the Solana system or EVM system, and this thing. For one who has the money and would want to yield APYs out of it, they have multiple ways. They can delegate their money to the node operators, and they can reap the benefits, and they can participate in this PBO and other things. Now, opening up the code bases and stuff will definitely come later for the public participation when the governance is decentralized, and that is definitely on the cards. Yeah.
Oh, sounds good. And so that first test net, does that contain does that have the container capability, or is it just the default container at the moment?
Yeah, this is only default container at the moment. We are still, as I said here, we are still sorry. This is a work in progress. The implementation we plan to make available early next year, more or less January. So we are working on two VMs simultaneously, the MoveVM and the EVM. Hopefully, we can bring in the containers as an upgrade to both VMs together.
Yeah, okay. Yeah, because I think I always say that, even if some other technology maybe technically is slightly better, there are so many people who know how to use programming Solidity and on the EVM that I think it's going to be very difficult for there to be a real competitor. But time will tell.
Yeah, it's yes, we are open for competition that way.
Yeah. All right. Well, look, thank you very much for your talk today, Raghavendra. Very interesting. Have a great rest of your day. And thank you for your talk.
Thanks, everyone. Thank you. Bye.
Bye-bye.